Hey guys, my name is Jared and I work for Western Power as an innovation facilitator. For my job, I need to understand what electricity is and how we move it around. So, electricity. The short version is everything around us is made up of atoms, including ourselves. And those atoms are made up of parts called neutrons, protons, and electrons. Electricity, as you may have already guessed because you're pretty smart like that, is to do with the electrons in atoms. When electrons get on the move in a purposeful, directed kind of way, that is electricity. Electrons are very different from protons. I'm going to get inside a model of an atom to show you. Protons are relatively large and heavy and kind of stuck in the middle of the atom. Inside here, like this big ball, they have a positive charge. Also, the nucleus is where the neutrons hang out, which are similar, but they have no charge. They're neutral. Electrons, on the other hand, are extremely tiny and light, and they're always buzzing around the nucleus. And they have a negative charge. This is a simple atom with only one of each type of part. But most atoms, especially metals, have many protons and neutrons in the nucleus, which is in the middle, and many electrons flying around the nucleus in a cloud. Now, usually atoms have the same number of positive protons as negative electrons. So even though protons and electrons are so different, at least their charges match up, which means they cancel each other out. And overall, that makes the atom uncharged or neutral. But with electrons being on the outside and being so light and whizzy, there is a possibility of maybe one or two of them getting detached from that particular atom. And that will mean that the atom becomes positively charged overall, with an overbalance of protons in comparison to electrons. The electrons will then carry that negative charge elsewhere. That movement of electrons outside of the atom and from one atom to another is the beginning of electricity.
Hello, I'm Donna, and I'm an electrical engineer from Western Power. And for my job, I need to understand how electricity is made and moved. There are more than one way to make electricity, but I will show you the main one. Magnetism and electricity are closely related. Magnets can make electricity and electricity can make magnetism. And it's all to do with that negative charge held by the electrons and their ability to move. When a magnet moves past a bit of metal like this wire, its magnetic field creates a force called an EMF, which can push electrons in the wire. Remember that movement of electrons is what we call electricity. By coiling the wire around many times, this EMF will be made in each bit of the wire, which will add up to a current big enough to hopefully show up on this ammeter, a current measuring device. Watch the needle. Here I put a pen in and out of the coil. Now I put a magnet. So the secret to making electricity, in simplistic terms, is to move a number of magnets through some coils of wire. And this is what a generator does. To make a lot of electricity, we need to make that big. So how do we move these magnets or wires? We use a turbine. We can turn the turbine using wind or water, or for example, in a coal power plant, we burn coal, use that heat to make steam, which can also turn a turbine. At Western Power, we engineers need to transfer that electrical energy to where it is needed in a safe and efficient way.
Hi, I'm Freya. Moving electricity is what Western Power does, and someone that knows a lot about that is Mike. Hey Mike, tell us about the network.
So this is a typical type of pole. You can see we've got a wooden pole with low voltage electricity on the top and one cross arm, which is the piece that goes across the pole. And on this side, we've got a high voltage pole and a low voltage pole. So on the top is the high voltage, underneath is the low voltage. And this pole happens to be steel. Our poles generally are wood, steel, concrete, or a composite mix. So you can see the big structure just at the back of me here, that's a transmission structure. So they're very high voltage. You've got 330,000 volts and 132,000 volts. So that's transmission. Then we come back to the stuff we've been looking at, which is the distribution network, which is generally 22,000 and low voltage.
Wait, Mike, How does it go from 300,000 volts in transmission lines to 240 in our homes and schools?
Basically what happens with this is where we change the amount of electricity that we put in a different part of the network. So we'd have a high voltage coming in on this side, which goes through the transformer, and then on this side of the transformer we get low voltage comes out. So these are the connections that would then go into your house to supply your house with electricity.
Thanks, Mike. Western Power is the 800,000 plus poles and towers, 100,000 plus kilometres of cable, 152 transmission substations, and almost 70,000 distribution transformers, covering an area of more than 250,000 square kilometres. Now that is some seriously big numbers and a lot to look after.
So Western Power takes care of getting electricity from where it is made to where it is needed. Our job is keeping the electrical circuit connected with a steady flow, stepping electrical voltage up and down so it can be transported efficiently and be of use to you.
It's not one electron that goes all the way around the circuit as well. One electron will be energized to move it, and it will then bump along another one, and that one will bump along another one, and so on and so forth until it makes it all around the circuit. So you keep having to put that bumping energy in at the power station to keep the circuit moving.